friends, so we are going to solve this problem. This problem is from net question paper that happened on July 28, 2025. Question ID is this. Question is, let Fi denote the field with 5 elements. How many 2x2 matrices with entries in Fi have rank 1? And these are the options given. From this we have to choose the right one. So before solving this problem, let us derive one beautiful result, and that result is that means we have to find out n cross n invertible matrix over the field of order p, and that field of order p is denoted in this way. Okay, so let us derive this result. Okay, so we have field of order p, its elements are like this up to p minus 1. So p elements are there in this field, and over this field we have to find out how many invertible matrices we can form over this field. Okay, and the order of that matrix is n cross n, that means square matrix. Okay, so let us talk about the first row. Okay, first row, first entry. So for the first row, first entry, it will have p choices, right? Because definitely entries will be from this field. Okay, so for the first entry it will have p choices. For the second entry also it will have p choices. Similarly for the last one, again it has p choices, right? It will have p choices, right? So total choices for the first row will be p raised to n, but among all these choices there will be one like this. Okay, that means all the entries are 0. That we don't want, right? Because we want invertible matrix. If any row of any square matrix is 0, though, so that matrix can't be invertible. Okay, so we don't want this kind of choice, right? So from p raised to n choices, I'll remove that. Okay, so this is the first row. Okay, now let's talk about the second row. For the second row, now since I want invertible matrix, so the second row can't be multiple of first row. Okay, so the second row, it says R2, if R2 is the second row, so R2 can't be multiple of R1, and definitely this alpha is any element from this field Fp. Okay, so for this alpha, how many choices I can have? P choices I have. And again for this element I'll have p choice. For this element also I'll have p choices. For all entries in the second row I'll have p choices, right? So total p raised to n choices, but among all these p raised to n choices, there will be p such choices which is the multiple of the first row, right? So we don't want that. So from this I have to subtract p. Okay, again let's talk about the third row. Okay, so again I want invertible matrix, so my third row, it should not be linear combination of, it can't be linear combination of first row and the second row. Okay, so R3 can't be like this. So again where this alpha and beta, they are the elements from field. Okay, so again for this alpha I'll have p choice, for this beta I'll have p choice. Okay, so total so there are total how many choices? P square choices. So there will be p square there will be p square choices such that this R3 will be linear combination of R1 and R2. Okay, and again this p for the first element of this third row, there will be p choices. For all the elements there will be p choices. Okay, so there are total p raised to n, and from that I have to subtract p square. because this p square choices are such that this r3, this third row, is a linear combination of r1 and r2. Okay, or similarly all this for the nth rows also. This is nth row. There will be how many choices? P raised to n minus p raised to n minus 1. Okay, why p raised to n minus 1? Because for the last row, I don't want this to be linear combination of above n minus 1 row, so I have to subtract this p raised to n minus 1, because this p raised to n minus 1, these are the choices where the last row is the linear combination of above n minus 1 row. Okay, so these are the number, so this much invertible matrix we can form over the field of order p. Okay, now let's go to our problem. So your field is what? F5. So that means this field is having 5 elements. Okay, and I have to construct 2 cross 2 matrices. Okay, we have to construct 2 cross 2 matrices. So so 24 into 20, 480. So 480 are the invertible matrix. Okay, now I want a matrix with rank 1. Okay, so from this 5 raised to 4, I'll subtract 5 raised to 4 is what? 625 minus 480. Okay, 145. Okay, but see, in this 5 raised to 4, these are the number for 2 cross 2 matrices, but among this I'll have this kind of matrix also. Okay, so this matrix, again, it is not, we say it's a matrix with 0 rank. Okay, so again, from this 145 I have subtract this one, so 144 is the right answer. 144.